All right, what's up, guys? In this video, we're going to pick up with some calculus here, and it's going to be another integration practice video. And in this video, we're going to tackle our first challenge integral. So what we're going to be evaluating today is the integral e to the square root of sine x multiplied by cosine x dx. So keep in mind that challenge integral is a personal statement, because how challenging an integral may be really depends on how good you are at integrating or where you are in your integration. So to some it may be challenging, to some it may not be challenging, but this was in the challenge section of the calculus textbook. I have the Pearson edition, the green book, that I kept after I graduated. And so I just decided to pick on this one. This one was not challenging for me at all because I've worked an integral like this before, somewhat similar, not completely similar to this, but somewhat similar. So it's not super challenging at all, but it is quite lengthy. So we'll go through it and I'll kind of explain everything. So let me know if you got any questions and we'll go ahead and start with it. So as I said here, this integral is not as bad as it looks. The first thing that I'm going to do is a u substitution. And notice how we can pick u to be sine of x. And we know this will work because sine's derivative is in the integral. And that's a key, idea that a u substitution will work if its derivative is somewhere in there. So we know that this is going to give us 1 over cosine of x du is equal to dx. And one of the reasons why I said this integral wasn't super challenging at all is because in the previous videos that we've done with our integration practice, notice what happens to this integral after we have done our initial substitutions. Hopefully you'll see that the cosines will cancel out. And look at what the integral becomes now. The integral becomes e raised to the square root of u du. Now, the reason why I said this was easy is because I believe a couple of days ago in integration practice video number 2, I believe, we did an integral that was somewhat similar to this. So this is an integral now that we need to evaluate e to the square root of u du. Well, for this one, we can also do another substitution. Now, keep in mind that when you're doing more than one substitution in a problem, you don't want to use the same variable. You typically want to use something else. Most students use v. They go to the next letter. It doesn't really make a difference what variable you use to do the next substitution, but you need to choose something different. Don't try to use u again because that's just going to be a nightmare for you. So use something different. So typically people use v, but I like to go a little unconventional. I'm going to use w. It doesn't matter what you use, as long as you're going about the process the same. So doing another substitution, I'm going to pick w to be the square root of u. And then that means that dw will be equal to 1 over 2 multiplied by the square root of u du. And then that'll give us 2 times the square root of u dw is equal to du. So we've solved for the du part. The 2 is a constant. That comes out front. And then that'll be times the integral e to the w multiplied by w dw. Okay, so hopefully you can see where we're at now. Now it's a simple integration by parts. We have e to the w times w. We have a product of functions. So let me remind you of the integration by parts formula, and I'll just denote the integration by parts with the abbreviation IBP apostrophe S. And we just get the formula from the product rule. It's just the integral of u dv is equal to uv minus the integral of v du. And again, this is a super easy integral. Don't forget about the constant that's on the outside. We'll deal with that in a little bit. But you remember how you go about this. You determine what u is and what dv is. And again, neither of these is harder to integrate or differentiate than the other. But in this case, let's pick u to be w, and then dv will be everything else. So dv will be e to the w dw. And that means that du is dw. And that means that v, remember how we get v, we integrate dv. So that's the antiderivative of e to the w dw, which you know is e to the w. You don't need to add a plus c there. We'll add a plus c at the end, and then you just kind of follow the formula. So it's going to be 2 times, and we just follow the formula. And so the formula is e to the w multiplied by w minus the antiderivative of e to the w dw, which we know is just e to the w. So this essentially becomes 2 times e to the w multiplied by w minus e to the w. And now when we go back to all the substitutions that we did, and particularly in cases like this where integrals, where you got a lot of work going on, first of all, you want to be neat anyway, but you definitely want to make sure that you're being extremely neat when you have problems that require multiple integration techniques, because you're going to have to go back and get all that information. And so if you got stuff all over the paper, it's going to be a little hard to go back and get what you need. So make sure you're doing stuff neat. You should be doing stuff neat anyway, but just a reminder on that. So remember, the first substitute that we did was u, that was sine x, or sine of x rather. And then the second substitution I did a little bit unconventional. I chose a different variable. But again, it doesn't really make a difference what you choose. The second substitution we did, w is equal to the square root of u. So all we really have to do is just plug that stuff back in. So we'll get 2 times e raised to the square root of sine of x, multiplied by the square root of sine of x, and then that'll be minus e raised to the square root of sine of x. And I'm going to go ahead and expand out the expression, and we can write our final answer down here at the end. So the final answer for this, we were asked to integrate the integral e to the square root of sine of x multiplied by cosine of x dx. And the answer to this would just be 2e to the square root of sine of x multiplied by the square root of sine of x minus 2e to the square root of sine of x. And then we need to add an integration constant. So we need to add a plus c. So that would actually be your answer for that integral. And we actually were able to get it done on just one sheet of paper, which I think is pretty cool. And that's how you evaluate that integral. So challenging is a relative term, depends on how good you are at integrating. But if you're pretty good with it, hopefully that wasn't one that was too difficult to tackle. So that's your answer for that. So let me know if you got any questions about it. I'll be more than happy to explain it. I'll see y'all next time.